Yeah, good evening, class 10 students. Good evening, children. Good evening, online children. Am I audible? Yeah, good evening. Okay, so today we are going to see a new chapter, areas related to circles. So first, let's understand the meaning of the terms sector and segment. Now, what is a sector? What is the sector of a circle? A sector of a circle is a region bounded by two radii and an arc. Sector of a circle is the region of a circle bounded by two radii and an arc. Now this is called the sector. This angle is called the sector angle, represented by theta. All right. If theta is less than 180 degrees, the sector is called a minor sector. And if theta is more than 180 degrees, the sector is called a major sector. If the sector angle is equal to 180 degrees, then the sector is a semicircle. The sector is a semicircle. When the sector angle is equal to 180 degrees. Can you see? Now this is a sector. Why is this a sector? Because here, two radii, radius, arc. If a region of the circle satisfies the definition of a sector, what is the definition of a sector? It should be a region of the circle enclosed by two radii and one arc. Any piece of the circle satisfying this definition is a sector. If you can see, the region has two radii, the region is bounded by two radii and one arc. It's a sector. So here, see here, two radius. This is one radius, this is the other radius, and an arc. Yes, it has. So a semicircle is a sector with sector angle 180 degrees. So this is a semicircle. When the sector angle is 180 degrees, it's a semicircle. So what is the sector? It's a region of the circle bounded by two radii and one arc. If the sector angle is less than 180 degrees, the sector is called a minor sector. If the sector angle is more than 180 degrees, the sector is called a major sector. And if the sector angle is equal to 180 degrees, it is a sector, but the special name is a semicircle. It's a semicircle. It's a sector. A semicircle is a sector. Okay. All right. Now, because a sector is a part of the circle, the area of the sector will definitely be less than the area of the circle. What is a sector? It's a part of the circle. Its area will be less than the area of the circle, because we know a whole is greater than its part, right? A whole is greater than its part, Euclid's geometry. Okay. Now, how do we find the area of the sector? Now, what will be this angle? This angle will be 360 minus theta. 360 minus theta. This angle will be 360 minus theta. So now if this angle is less than 180 degrees, then this is the minor sector. So the rest of it is the major sector. The rest of it is the major sector. Circle, if you call this the minor sector, then the rest of the circle is the major sector. The rest of the circle is the major sector. That also is, see, the rest of the circle is like this, two radii and one arc, like this it is, the rest of the sector. The rest of the circle is also a sector. This is the minor arc. Oh, sorry, this is the minor sector. This one is the minor sector. The rest of it is also a sector, which is the major sector. How does that look? Two radii and an arc like this. Correct? This is the major sector. Major sector angle. This is the major sector angle. This is the major sector. We can see the two radii and an arc. And this is the minor sector. This one is the minor sector. Theta 360 minus theta. Correspondingly, this arc is called the minor arc because it's an arc of the minor sector. So it's the minor arc. And this arc is called the major arc. See, on the boundary of the sector, there are three things. On the boundary of the sector, there are three things. What? Two radii and the length of an arc. Radius plus length of arc is the perimeter of the sector. What's the perimeter of the sector? Radius plus length of arc. For the major sector also, radius plus length of major arc is the perimeter of the major sector. Radius plus the length of the major arc is the perimeter of the major sector. So if the arc is a part of the minor sector, it's a minor arc. If the arc is a part of the major sector, it's the major arc. Okay. So what are the terms? Sector, minor sector, major sector, then semicircle. Semicircle is also a sector where the sector angle is 180 degrees. And sector means it should have it's a region enclosed by two radii and one arc. The arc can be a minor arc or a major arc. If it's a minor sector, minor arc. Major sector, major arc. Angle in the minor sector, less than 180 degrees. Angle in the major sector, more than 180 degrees. Now, how do we find the area of a sector? Okay, so how do we find the area of this region? Now, this is some fraction of the whole circle, right? The sector occupies some fraction of the whole circle. What fraction of the whole circle? Theta by 360. The fraction occupied by this sector is theta by 360. Now, supposing the sector angle is, say, like 60 degrees. Okay, so 60 by 360, which simplifies to 1 by 6. This sector occupies 1/6 of the area of the circle. Okay. If the because the complete angle around the center is 360 degrees. Okay, and if this sector angle is 60 degrees, 60 out of 360. 60 degrees out of 360 degrees, 1 by 6. So this sector occupies 1/6 of the area of the whole circle. So what will be the area of this sector? 1 by 6 into pi r square. 1 by 6 into pi r square. Because if it occupies 1/6 the area of the whole circle, then its area also will be 1/6 of the area of the circle, which gives us this formula. Area of the sector is equal to theta by 360, whatever fraction, into pi r square. This is the formula to find the area of a sector. Area of sector is equal to theta by 360. Yeah, whatever is the sector angle divided by the total 360, that fraction into pi r square. Into pi r square is the formula to find the area of a sector. Online children, I didn't ask you this usual question. I've shared my screen. Is it visible to all of you? Am I audible?
Yes, ma'am.
Very good. Thank you. So that's about the area of a sector. If it's the major sector, what's the major sector angle? 360 minus theta. Whatever is this, if you want to find the area of the major sector, you should write the major sector angle in the numerator. You should write the sector angle of that sector whose area you want to find. If you want to find the area of this sector, then the corresponding sector angle. So in this case, it will be 360 minus theta. If this is theta, then this is 360 minus theta. This is the major sector. This is the minor sector. Area is equal to theta by 360 into pi r square. Area is equal to 360 minus theta by 360, whatever is that sector angle. 360 minus. Now, supposing you're given that sector angle directly, then you should not do 360. Supposing this is given directly, this is say some 270. And you have to find the area of the sector. Don't do 360 minus 270. That sector angle is given directly. So theta 270 by 360. So if this is confusing, what is this theta 360? Sector angle by 360 into pi r square. General formula. Sector angle. Whichever sector's area you want to find, that sector angle by 360 into pi r square. So in general, we say for minor sector, if the minor sector angle is theta, then the major sector angle is 360 minus theta. So keeping this as the basis, we say area of minor sector is keeping this as the basis, we say area of the minor sector is theta by 360 into pi r square, and major sector is 360 minus theta by 360 into pi r square. How do we understand? Sector angle by 360 into pi r square. That's all. All right. Yeah, please write down now. And perimeter you understood. Radius plus length of path. You have a question? Area of same thing. 180 by 360 into pi r square. So it will be 1 by 2 into pi r square or pi r square by 2. Semicircle what? Pi r square by 2. No, same thing you will get. Even if you use this formula, same answer you will get. 180 by 360 into pi r square. So 1s are 2s are. So 1 by 2 into pi r square. Correct? No, pi r square by 2 it is. Yeah, please write down. Done? All right. So what is 2 pi r? 2 pi r gives you the length of the circle. 2 pi r gives you the length of the boundary of the circle. 2 pi r, okay, gives you the length of the boundary of the circle. Now, what is this length of arc? It's a part of the boundary, right? It is some part of it occupies, not occupies. This length of arc is a part of the boundary of the circle. So, what part of the boundary of the circle? Full boundary is 360. This one occupies 60 degrees. So 60 by 360. So again, theta by 360 into 2 pi r. That same fraction into 2 pi r will give you the length of arc. Okay, because 2 pi r is the length of the full circle, the length of the boundary of the circle. And on the, where is this length of arc? It's on the boundary, right? So what will be the fraction for this L? Theta by 360. What will be the length of this arc? Into 2 pi r. Into 2 pi r. Similar, the way you understood this. So length of arc is equal to theta by 360 into 2 pi r units. Yeah, yeah. Done? Or 1 minute for major sector. I'll just draw this portion. 1 minute. Sorry. Here also, I'll just show the major sector alone. I'm sorry, minor sector alone. I just want to correct this. What if I have neatly considered? Finished this one also? What's a segment? A segment is a, just draw this more clearly. Yeah, children. Okay, so a segment is a region of the circle bounded by a chord and an arc. This is the chord, arc. The region bounded by a chord and an arc is called a segment. This is a segment. The region of the circle bounded by a chord and an arc is called a segment of the circle. Now, the minor segment will be a part of the minor sector. Okay, the minor segment will be a part of the minor sector. Yeah, and you can see that the minor segment does not contain the center of the circle. See, this is the minor segment. The center of the circle is outside here somewhere. The minor segment does not contain, that is the center of the circle does not lie inside the minor segment. The center of the circle does not lie inside the minor segment. The center of the circle is outside the minor segment. So the minor segment does not contain the center of the circle. So this is how the minor segment looks like. Minor sector, minor segment is a part of the minor sector. Sector is 2 radius and 1 arc. Segment is a chord and an arc. So you can see this is the chord. This is the arc. So if it's the minor segment, this is the minor arc. Now, how do you find the area of this region? How do you find the area of this region? We have 3 cases. Let's take the next slide. Okay. Theta 120 degrees is removed from your syllabus. So we have only 60 and 90. So AOB, triangle AOB, when theta is 60 degrees, is an equilateral triangle because AOB is already an isosceles triangle. AOB is already an isosceles triangle because this is radius, this is radius. It's already isosceles. Now, when this is 60 degrees, we know that these two angles are equal. So when this is 60, 180 minus 60 is 120. So each of these angles will be 60, 60. So when the sector angle is 60 degrees, triangle AOB is equilateral. Correct? Because sector angle is 60. So remaining is 180 minus 60, 120. But these two angles are already equal because radius, radius. So it's an isosceles triangle. The base angles are equal. So 120 by 2, 60. So that makes all the angles 60 degrees, which means the area of the triangle is root 3 by 4 into side square. It's an equilateral triangle. Area is equal to root 3 by 4 into side square. Correct? Now, when the sector angle is 90 degrees, it's a right triangle. When the sector angle is 90 degrees, it is a right triangle. And area of a triangle is equal to half base into height. Half base into height. So if this is 90 degrees, this is the base, this is the height. This is the hypotenuse. This will not come in area calculation. This is the hypotenuse. Leave that. Half into base into height. So basically half into radius into radius. Half into base into height, it's half into radius into radius. If it is 60 degrees, root 3 by 4 into side square. The side is the radius. Now, when this triangle is equilateral, the chord is also equal to the radius. The length of the chord is equal to the radius. When the sector angle is 60 degrees, all the sides are equal. So the length of the chord AB will be equal to the radius of the circle. Correct? When it is 90 degrees, half base into height. So half into radius into radius. Hypotenuse, this is hypotenuse, opposite of the right angle. That will not come in area calculation. Half base into height. Okay. So it's nothing but half into R into R. Half into R into R, always. So half R square, always. What's the question? Factorize that expression. Factorize that. You can try grouping the first two terms and the last two terms. Try. First you try grouping. First two terms and the last two terms. If grouping does not work, then you should use that factor theorem to factorize it. Yeah, you can find the factors using synthetic division. So you first try grouping. 2x cube, what's the next term? Grouping will not work. You have to factors using factor theorem. So you'll find the three factors, no? Then if this is the length, that's the breadth, that's the height. You'll get three factors like say x minus 5 into x plus 1 into x minus 3. So if x plus 5 is the length, the other is the breadth, the other is the height, like that. Factorize and tell me. Okay. So these are the two cases. And you understand, right, why we are subtracting? Because what is the sector made up of? The sector is made up of a triangle and a segment. What is the sector made up of? Sector, it's made up of a triangle. The sector is made up of a triangle and a segment, right? So how will you find the area of the segment? It's the area of the sector, the area of the full thing, the area of the sector minus the area of the triangle will give you the area of the segment. The sector is made up of, the minus sector is made up of a triangle and a segment and the minor segment. So from the area of the sector, if you take away the area of the triangle, you can find the area of the minor segment. And the triangle can be an equilateral triangle, in which case the area is √3/4 into side square, or it can be a right triangle, in which case the area is half base into height, which is half into R into R. And how to find the area of the sector? We know theta by 360 into pi R square. Okay, we need to work also, okay? So that's about finding area of minor segment. Area of major segment. Oh, I didn't define major segment. No, 1 minute. I didn't define a major segment. So you can see that the major segment will contain the center of the circle. Why don't we just ignore that then? Go to the next one. Don't Google the answers. Yes. Oh, you're finding the question on WhatsApp, is it? Okay. Okay. So major, what is segment? It's a region bounded by a chord and an arc. Chord and arc. Okay. Now you can see that the major segment contains the center of the circle. The major segment will contain the center of the circle. This. Now this is the major segment. No, this yellow representation. This one. This one is a major segment, right? What do you see inside a major segment? You see the major sector and the triangle. Can we see that? See, this is the minor segment here. This is the minor segment. This is the full circle now. This is the full circle. What do you see in a major segment? The major segment is made up of the major sector and the triangle. The major segment is made up of the major sector and the triangle. There are two ways of finding the area of the major segment. One is area of the full circle minus the area of the minor segment. Area of the full circle minus the area of the minor segment. I'll give you the area of the major segment. Because minor sector plus major sector is the circle. Minor segment plus the major segment is a circle. When you put the two pieces together, see here. This is the minor sector. And this is the major sector. This is a major sector. If you fix this piece here, it will become now this major sector and the minor sector. If you put them together, that will make the full circle, right? If you put this piece here, it will make the full circle. In the same way, the major segment plus the minor segment, if you fix them together, that will be the full circle. This is the minor segment. This is the major segment. The minor segment will not contain the center of the circle. The major segment will contain the center of the circle. If you put the major segment and the minor segment together, that will make the full circle. If you put the minor sector and the major sector together, that will make the full circle. So, see, this is the major sector. This is the major sector. To that, you add the triangle. This is the major segment. This now this full thing is the major segment. Erase this one. This is the major segment. So what is inside the major segment? Inside the major segment is a major sector and a triangle. So you can find the area of the major segment in two ways. Area of circle minus area of minor segment. Or area of the major sector plus the area of the triangle. This is okay? Okay. And we have a quick formula to find the area of sector is equal to area of sector is equal to LR by 2 square units. Very important for 1 mark. area of sector is equal to LR by 2 square units. If you're finding the area of the, okay, you write down. Done, all of you? Whose parent is there? Yeah, done, all of you? Oh, oh yeah. Yeah, you can leave. Yes. I'll just see your work. Come here. Show me your work and you can go. Yeah. Now, if you're finding the area of the major sector, then length of the major arc. If you're finding the area of the major sector, just a second. You've only been writing the questions. Huh? You don't answer anything. Hello? Hello? Yeah, thank you, children. So I was telling you, yeah. So area of, if you're finding the area of the minor sector, then L will be the length of minor arc. If you're finding the area of the major sector, L is the length of the major arc. What is L? Length of arc, right? So we have two arcs, major arc, minor arc. If you're finding the area of the minor sector, then you should substitute the length of the minor arc. If you're finding the area of the major sector, you must substitute the area of the major arc. Area of sector is equal to LR by 2. LR by 2 square units. Yeah, I think this is sufficient. We can get started with the questions from this chapter. So further, I'll tell you as and when needed, okay? Yeah, right now. Shorting. Thank you, Keshav, for the message. My mic was on mute and I was talking. What are the others doing, by the way? Thank you, Keshav. Yes, I was explaining this answer, but I didn't notice my mic was on mute. Okay. I just started talking, no, after writing. Okay, so the question is, I'll just repeat. 3 horses are tethered with 7-meter long ropes at the 3 corners of a triangular field having sides 20 meters, 34 meters, and 42 meters. We'll have to answer 2 questions. Find the area of the plot which can be grazed by the horses. How much area of the plot can be grazed by the horses? And also find the area of the plot which remains ungrazed. So I was saying there's a pole and you hold the pole. There's a pole, you hold the pole with your hand. You keep your hand fully stretched and you go around the pole. So you will be tracing the boundary of a circle, right? In the same way here inside the field, we have 3 horses tied to the vertices A, B, and C, tied to the corners A, B, and C with ropes 7 meters long. So what is the maximum, area that each horse can graze? So assuming that this horse, which is tied at corner A, it keeps the rope fully stretched and it tries to walk. It'll trace a sector. It'll trace a sector. Because if it goes outside the field, it can trace a circle. Inside the field, it will trace a sector. If it is able to go 1 full round, yeah, then it will trace a circle. But then it's a plot, it's a field, there's a boundary, no, it cannot go outside the field. So it will trace a sector, which is a part of a circle. Same thing with the horse tied at B. The length of the rope is 7 meters long. When the rope is fully stretched and the horse moves around, it will trace a sector. Same thing with the horse tied to the corner C. So the area of the field or the plot that can be grazed by the 3 horses is equal to the sum of the areas of the 3 sectors. Sum of the areas of the 3 sectors. So how do you find the area of a sector? Theta by 360 into pi r square. What is theta here? Angle A. What is theta here? Angle A. Angle A by 360 into pi r square plus angle B by 360 into pi r square plus angle C by 360 into pi r square. By mistake, I put an into here. Sorry. Plus. Plus, children, I just corrected this. By mistake, I put a multiplication sign there. Sorry. Plus angle A by 360 into pi r square plus angle B by 360 into pi r square plus angle C by 360 into pi r square. Now, we don't know the angles. We can't find the area of each sector in this question. Area of each sector we cannot find because we don't know the sector angle. We can only find the sum of the areas of the 3 sectors. We cannot find the area of each sector in this question. So the sum of the areas of the 3 sectors is what we have written here. So take out pi r square by 360 common. So you'll have angle A plus angle B plus angle C inside the bracket, right? You can see everywhere pi r square by 360. This is one expression. It has pi r square by 360. Another expression, it has pi r square by 360. Another expression with pi r square by 360. So that's common. So if you write this outside, what remains? Angle A plus angle B plus angle C in the bracket. Now what is angle A plus B plus C? 180 degrees, sum of the 3 angles of a triangle. So pi r square by 360, this pi r square by 360 into 180. Ones are twos are. So pi r square by 2. What is pi? 22 by 7. R is 7. So r square 7 into 7. And the 2 which is in the denominator here. This 2. Put that 2. So that simplifies to 77 meters square. So this is the sum of the areas of the 3 sectors, which is the area that is grazed by the 3 horses. Now ungrazed will be area of the triangle minus area of the 3 sectors. So to find the area of the triangle, use Heron's formula that I'm not explaining. You've already seen that in 9th standard. S is equal to A plus B plus C by 2. And area is root of S into S minus A into S minus B into S minus C square units. And here you should not multiply 48 into 28 into 14 into 6. Do not multiply them. Break down the number into their, break down every number into their prime factors. Write 48 as a product of its prime factors. So how do you write that? You can, don't do this method and waste time. 48 is what, like you can just do it in your mind. 16 into 3, right? So 16 is what? 2 to the 4, 4 to the 8, 8 to the 16 into 3. Just break down the numbers in your mind. What is 28, 7, 4, 7? What is 4, 2 into 2? So 2 into 2 into 4, 7. What is 14, 2 sevens are? And 6, 2 threes are. You can think of 48, you can think of 48 as 6 8s are 48 also. 6 8s are 48. What is 6, 2 into 3? What is 8, 2 into 2 into 2? Any tables. Use any tables and break down the numbers. You can think of 28 as 7 into 4 or 14 into 2 also. Anything. So 14 should be further written as 2 into 7, like that. The rest is very easy for you to understand. So the area of the triangle is 336 meters square. So the area ungraced is 336 minus 77, which is 250. Next one. Just turn off the light and come. Thank you. So ABCD is a trapezium, AB parallel to CD. Distance between the parallel sides, AB and B, the distance between the parallel sides AB and CD is 14 centimeters. And the radius of each sector is 7 centimeters. And you know all the four sides of the trapezium, 16, 18, 17, and 32. Given all this, we should find the sum of the areas of the four sectors. So the sum of the areas of the four sectors will be angle A by 360 into pi r square. Sector formula, area formula is sector area formula, theta by 360 into pi r square. So theta is angle A here, angle A by 360 into pi r square, plus angle B by 360 into pi r square, plus angle C by 360 into pi r square, plus angle D by 360 into pi r square. But we do not know the measures of these angles. So take out pi r square by 360 common. Then you will have angle A plus angle B plus angle C plus angle D in bracket. But what is that sum? 360. So 360 and 360 will get cancelled. So pi r square, the area of the four sectors is pi r square. You'll have to show all these steps. This pi r square. Then how do you find the area of the shaded region? Area of the trapezium minus the area of the four sectors. Shaded region. What I the striped region. Shaded is the striped one here. I have not shaded actually. See this one. When I say shaded region, I'm talking about this region. The checked region. The area of this checked portion will be area of the trapezium minus the area of minus the sum of the areas of the four sectors. Correct? And then the perimeter of the shaded region. How do you find the perimeter of the shaded region? See here. This is the shaded region. See here. Please watch. This is the shaded region. So here you have the sector. See, I'll just show you what I've done. I'll just show you 1 minute. It is a shaded region. I'm just showing you I'm highlighting the boundary of the shaded region. I'm highlighting the boundary of the shaded region. All of you agree? This is the boundary of the shaded region. Okay, so what's the perimeter of the shaded region? What is the total length? AB 18. How much is it from here to here? 7. What's the radius of the sector? What's the radius of the sector? Radius of the sector is 7, right? 7. So this one from here to here is 7. And from here to here is also 7. So 18 minus 14, 4. This portion is 4. This portion is 4. Yeah. Then what about this one? This is the length of arc. This is the length of arc. This one also, this one, and this one. All these 4 arcs put together will make the circle 2 pi r. Because the 4 sectors put together is a circle, right? What is the area of the 4 sectors? Pi r square. So similarly, if that is pi r square, then these 4 arcs, when you put it together, it will make the boundary of a circle. It will make the boundary of a circle, right? So the length of all these 4 arcs will be 2 pi r. The length of all these 4 arcs put together will be 2 pi r. Correct? Okay, then what are the remaining portions? This one. How much is that? That'll be 16 minus 7 minus 7. So 2. And here it will be 32 minus 7 minus 7. So 32 minus 14. 18. And here it will be 17 minus 7 and 7. 17 minus 14, which is 3. All right. So this is how we answer the question. Do it. I've done my part. Yeah, please try this. And how do you find the area of the trapezium? Half sum of the parallel sides into distance between them. Area of a trapezium is equal to half sum of parallel sides into distance between them. Get started. Just 1 minute. Taking the question. Sorry. Let me write it immediately. 1 second. It's the same thing, but Correct? So what were the questions? We had to first find the sum of the areas of the 4 sectors. Again, here we don't know the sector angles. The individual sector angles we don't know. So we had to find the sum of the areas of the 4 sectors. Okay, so that was the first part. Second part is to find the area of the shaded region, that checked region. How do you find that? Area of the trapezium minus the area of the 4 sectors. 4 sectors area we already found. Area of trapezium. Formula, half sum of parallel sides into distance between them. All given in the question. Parallel sides, you know, so sum of the parallel sides into distance between them. Okay. Then area of the shaded region will be area of the trapezium minus area of the 4 sectors. Then finally, we have to find the perimeter of the shaded region. So for that, you should know the boundary of the shaded region. To find the perimeter, you need to know the boundary of the shaded region. So you can, I have shown, meaning I have highlighted the boundary of the shaded region. And I hope you understand. So see here. And now just do it in red. This is 4 plus this is length of arc. We don't know the length. Individual length of arc we can't find because we don't know the sector angle. We can't find. Plus this one is 3 plus length of arc. We can't find separately. Plus this is 18 plus length of arc plus 2 plus length of arc. So there are, apart from these 4 line segments, how many pieces are there? 1, 2, 3, 4 line segments and 4 arcs. 1, 2, 3, 4 arcs. In total, how many pieces we have on the boundary? 1, 2, 3, 4, 5, 6, 7, 8 pieces we have on the boundary, which is made up of 4 line segments and 4 arcs. The length of the 4 line segments we found. The 4 arcs together we can find. Angle A by 360 into 2 pi r, correct? Angle B by 360 into 2 pi r. If you multiply by 2 pi r, you will be able to find the length of arc. Because arc is on the boundary. Boundary is 2 pi r. Arc is on the boundary and boundary is 2 pi r. So if the length of the full circle is 2 pi r, if you want to know the length of a part of the circle, that is an arc. It's theta by 360 into 2 pi r. This full thing is 2 pi r. No, I don't want to know the length of this full thing. I just want to know the length of this arc. Or I want to know only the length from here to here. I want to know only this length. I want to know only this length. So I'll find this length. This is a part of 2 pi r. Okay, so what's the corresponding sector angle? The corresponding sector angle is theta. So to find the length of this arc, it will be theta by 360 into 2 pi r. So you can see that 2 pi r by 360 is common. Then this is replaced with 360, cancels, and all right. Sorry. Clear? Sorry. Yeah, please work this. I want the answer from one of you. I'm not working this. Please work this and share the answer with me. Online children use the emoji. Raise your hand. Okay, Aragamai, Akshada, Swati, Blessy, Srivatsan, Tanishka, Niveda, and Pratish, are you there? Yes, I want the answer from one of you, or a few of you, or all of you. I'll be very happy. Got it? Yeah. 44 by 7 r square. 44 by 7 r square. Why that hesitation, Tom? Perfect. Very good. So I got the answer from two of us here, Bhavishya and Hasif, Mohammed Hasif. 44 by 7 r square. 44 by 7 r square is the correct answer. What is the sum of all the angles of a hexagon equal to? What is the sum of all the angles of a hexagon equal to? Correct. How do you get 47 by 7 r square? Come here, Hasif. This is r square. R into r is r square. That's what this one be 22 by 7 into r square you have got. This is wrong. 360 is wrong. Okay, so Bhavishya got the right answer. 44 by 7. Let's see how it is. So how do you find the sum of all interior angles? Sum of all interior angles of a polygon. Any polygon, whether it is regular, not regular, any polygon, sum of all interior angles of a polygon is given by n minus 2 into 180 degrees. So here 6 sides. So 6 minus 2 into 180. 4 into 180, 720 degrees. The sum of, okay, therefore, sum of all the 6 interior angles of the regular hexagon is equal to 720 degrees. Now, the sum of the areas of all the sectors will be equal to angle A theta by 360, angle A by 360 into pi r square plus angle B by 360 into pi r square plus angle C by 360 into pi r square plus angle D by 360 into pi r square plus angle E by 360 into pi r square plus angle F by 360 into pi r square. So what's common? Pi r, no, what's common? Pi r square by 360. And in bracket, angle A plus angle B plus angle C plus angle D plus angle E plus angle F. So pi r squared by 360 into 720. So it is 2 pi r squared. So it is 2 into 22 by 7 into r squared. R we don't know. So 44 by 7 into r squared square units. We don't know the radius. Radius, nothing is given. Our radius is r. Okay. The radius of each sector is r. The number, the numerical value is not given. Right? Yeah. Please take down. Both one, right? Or instead of saying segment 1, no, I'll just take this as this mark another point. Just mark this point as E. Sorry. Sorry. Okay, so what are the different shapes you can see here? It's given there's a semicircle with LMS diameter. Semicircle with LMS diameter. Okay. Then there's a rectangle ABCD. Okay. And then we also see a triangle AOB. And we also see a sector OAEB. We see a sector OAEB is a sector. 2 radius and 1 arc sector. Now, how do you find the area of the shaded region? The area of the shaded region is the area of the rectangle ABCD minus the area of the segment. So minus the area of the segment. Which segment? AEB, this one. This one is a segment. This is a segment, right? So area of the shaded region is area of the rectangle minus area of the segment. Area of the rectangle, okay, L into B, we can find 20 into 10, we'll find. But area of segment is, we have to find, right? So how to find the area of the segment? Area of the segment is area of the sector OAEB minus the area of the triangle. Because what is the sector made up of? The sector has 2 pieces, triangle and segment. What is the sector made up of? Triangle and segment together is a sector. So to find the area of the segment, find the area of the sector and take away the area of the triangle. We'll get the area of the segment. So now what to find first? We should find the area of the sector. Find the area of the sector. For that sector angle, so to find the area of the sector OAEB, we need the sector angle. We need the sector angle AOB. So what is angle AOB? We should start here. What is angle? From here we should start. One thing leads to another, no? So கடைசியில் எங்க வந்து நின்று இருக்கோம்னா angle AOB தெரிஞ்சாதான் ஆன்சரே பண்ண முடியும். So how to find the measure of angle AOB? We can use trigonometry. But it should be a right triangle. To use trigonometry, we should have a right triangle. No right triangle. Correct? So how to find the angle? So here is how to find the angle. என்னடா இந்த மிஸ் விட்டுருவாங்களா இல்லையா எனக்கு 9:30க்கு செம்ம ஆரம்பிச்சிருக்காங்க. So this is 10 root 2. This is 10 root 2 and this is 20. See here, because this is the radius, no? OL is the radius, 10 root 2. OA is also radius, 10 root 2. நான் explain பண்ணச்சே நீங்க எழுதுறீங்க எப்படி புரியும்? What is OL, children? Radius, right? 10 root 2. What is OA? Radius, 10 root 2. What about OB? Radius, 10 root 2. From the center to any point on the circumference is radius. Okay. And then how much is the AB? 20. Okay. So OAB. AB is 20. OA, OB radius 10 root 2. Now, which is the longest side here? AB. Because 10 into 2 is 20. 10 into 2 is 20. So 10 into root 2 will be less than 20, no? Root 2 is less than 2. Root 2 is less than 2. 20 is what? 10 into 2. What is 10 root 2? 10 into root 2. So definitely 20 is the longest side. 20 is the longest side. Okay. Now we'll try to use the converse of Pythagoras theorem. We'll find the square of the longest side. AB square is equal to, normally we find in this order. We normally find OA square plus OB square. That is the sum of the squares of these two sides, the two shorter sides. 10 root 2 the whole square plus 10 root 2 the whole square. The sum of the squares of the two shorter sides. 200 into 2, 200 plus 100 into 200, 400. The square of the longest side, 400. So that means, therefore, OA square plus OB square is equal to AB square. Therefore, by converse of Pythagoras theorem, AB is the hypotenuse, no? So angle AOB is equal to 90 degrees. By converse of Pythagoras theorem, angle AOB is 90. If the square of one side of the triangle is equal to the sum of the squares of the other two sides, then the angle opposite of the longest side is a right angle. In a triangle, if the sum of the squares of any two sides is equal to the square of the third side, then the angle opposite of the third side is a right angle. So here the longest side is 20. The angle opposite to 20, that is angle AOB, is equal to 90 degrees. See, first we identified the longest side, no, 20. We kept that separately. We found the sum of the squares of the other two sides, 400. The sum of the longest side, 20. The square of the longest side, 20, 400. So since OA square plus OB square is equal to AB square, the triangle, the sides form a right triangle. And which is the right angle? Opposite of the longest side. Which is the longest side? AB. Which is the angle opposite the longest side? AB. AOB is 90 degrees. So it's a right triangle. And we also found the sector angle. We found two things. We found the sector angle and we also know it's a right triangle. So its area is half base into height, half into R into R. Okay. Now find the area of the sector. So see here, see the, the order in which we have to work. We have to find the area of the segment. Sorry, we'll have to find the area of the shaded region, right? To find the area of the shaded region, it is area of the rectangle minus the area of the segment. Please focus. Area of rectangle minus area of segment. Rectangle's area we can find because we know length and breadth. Segment we have to find. Okay, so to find the area of the segment, it is the area of the sector minus area of the triangle. Okay, that means you should find the area of the sector then. But to find the area of the sector, we need the sector angle. We know the radius, 10 root 2. We don't know the sector angle. We'll have to find the sector angle. So we have to find angle AOB. In the first place, we'll have to find angle AOB, and angle AOB is 90 degrees. Now, what's the area of the sector? Area of sector. What's the name? OAEB. OAEB is equal to angle, sector angle AOB by 360 into pi r square. That is 90 by 360 into 22 by 7 into r, 10 root 2. 10 root 2 into 10 root 2. 91.4 using the calculator. So 10 root 2 into 10 root 2 is what? 100, 200. 200 into, yes, you can further cancel 2 and 11. Correct? I think pi should be given 3.14 here. It's not given. Okay, we have to use, we'll have to, then I'll leave it as a fraction, okay? So 11 into 50, right? Are we seeing that? 11 into 5, 55. Then root 2 into root 2 is 2. So 110, that is by 7. Am I right? Hundred and ten by 7 meter square, centimeter square. Oh, the 0, yeah. I know I'm bad with calculations. What is in the numerator? We have 11, we have a 5, we have a 10, and root 2 and root 2 is just 2. 55? Yeah. 110 followed by 10 by 7, correct? Centimeter square. What's the area of the triangle? Area of triangle AOB is equal to half into base into height. Half into OA into OB. OA into OB. So half into 10 root 2 into 10 root 2. So this will get cancelled. 2 and this 2 and this root 2 will get cancelled. So it's 100 centimeter square. Correct? Area of the triangle. Now the area of the sector minus area of the triangle. You can take the fraction, find the LCM and do it, okay? Now the area of the sector minus area of the triangle will give you the area of the segment. Correct? Now the area of the rectangle minus area of the segment will give you the area of the shaded region. Can you complete this since it's time and it's also a fraction I want? It might take another 10 minutes for me to finish. I'll share these pictures, complete it, and we'll meet tomorrow. All right? I just have an announcement to make. Please hold on, children.